Well, hello from a very, very, very windy Wellington today. If you can hear that outside, it sounds like a 747 taking off. It's not, it's just the wind. It's on the verge of, I think, being a tropical cyclone. It's pretty windy. The weather station says it's gusting up to 130 kilometers. It's way more than that. There's a heavy rain, heavy wind. It's really, really windy. So hopefully you're all keeping well, keeping safe. Anyway, that's not our problem. We're here to do level 2 mathematics and statistics from 2018 applied calculus methods. So this is calculus of polynomials, sort of a taster of calculus. So without much ado, let's do it to it. Okay. So question 1, a function f is given by this thing here. Oh, there's a big gust of wind. X cubed minus 6x plus 2. Find the gradient where x equals 4. So to find the gradient, we have to differentiate it. So if f of x is this, then f dash of x is going to be 3x squared minus 6, and we're going to put x equals 4 in there, so f dash 4 is going to be 4 squared minus 6, so 4 squared is 16, so 3 times 16 minus 6, and that's going to be 3 times 16 minus 6, 42, isn't it? 3 times 16 is 48, minus 6 is 42, yeah. So the gradient is 42, and really we should say 42 over 1, because it's rise over run. Okay, so far so good. Okay, next question. A rectangle is expanding in area so that at all times the length is 3 times its width. So, wow, listen to that wind. So let's call that x, let's call that 3x, and find the change in area. So so we're going to be using differentiation to its width when the area is 75 centimeters. So the area is going to be 3x times x. So the area is going to be 3x times x, which is 3x squared. So when the area is 75, let's find out what x is. So 3x squared equals 75. Divide both sides by 3. So x squared equals 25, and it's going to be pretty simple. So x is going to be plus or minus 5, but you can't have a negative length, so x is going to be 5. So I'm going to save that till later. So if the area is 3x squared, then we difference the area. 3 times 2 is 6x, and we sub in the 5 now. So the change in area 5 is going to be 6 times 5, which is 30. Now what's the unit going to be? So 30, I guess it's going to be centimeters squared per centimeter, I guess, which is going to cancel, so it's going to be 30 centimeters. I think that's right. That would have to be the unit, yeah, because it's change in area over change in length. Yeah, it's going to be 30 centimeters. Okay. All right, so the derivative of the function f is given by this, and it passes through this point 0.05. Use calculus to find the local maximum of the function. Okay. Find the value of the local maximum. So I guess we need to set this thing equal to 0 and solve to find a turning point. Okay, well, we've got f dash of x, and we know that it's this. So therefore, when we integrate it to find f of x, the -3 stays there, the x stays there, we grow 1 in the exponent, and we have to divide by that. And the 12x stays there, the 1 becomes a 2, we have to divide by 2, and we add a c. So they're going to cancel. So that's going to go to 6. So we're going to get -x cubed plus 6x squared plus c. And we need to find the c. So when x equals 0, y equals 5. So I mean 0 cubed is 0. 0 squared is 0. So c equals 5. So our original function is going to be minus x cubed. Wow, listen to that wind. Plus 6x squared plus 5. Okay. Now we need to find the local maximum, but we already know f dash of x is going to be equal to -3x squared plus 12x. So we're going to set that equal to 0 and solve for x. We can factor out a 3x. Yeah, we can factor out a 3x from there. So -x plus 4 equals 0. So this bit here, so x is equal to 0. So this is already a turning point. And -x plus 4 equals 0. So x is going to be equal to 4. So which one of these is the maxima and which one of these is a minima? Let's double differentiate it just because we can. So it's going to be -6x plus 12. When we put in 0, we're going to get a positive number, so that's going to be a minima. And when we put in 4, so -6 times 4 plus 12, that's going to be a negative number, so that's going to be a max. So it's maximized when x equals 4, but then we need to work out what it actually is. So we need to go to the original function here and put in 4 and work out what that is. So if you're following me so far, so -4 cubed plus 6 times 4 squared plus 5, and I'm going to use the calculator because I have no idea what that is off the top of my head. -4 cubed is that, plus 6 times 16 is 4 squared is 16, is that, plus 5 is 37. So that would be our final answer, 37. x equals 4. Okay. Okay, so use calculus to find the values of x of the graph where it's increasing. So where it's increasing, the first derivative is greater than 0, it's a positive number. So we need to find the f dash of x. So let's do it straight away. So 3 times 2 over 3 is 2x squared, plus 2 times 9 over 2 is 9x minus 5. And that's got to be greater. We want the values for which that is greater than 0. So first thing we're going to do, I guess, is find out where it equals 0. So 2x squared plus 9x minus 5 equals 0. And I'm going to, I think we're going to factorize this. Okay, so 2 times negative 5 is negative 10. So it's going to be plus 10 and negative 1. So 2x squared plus 10x minus 1x minus 5, and that equals 0. Then we're going to divide and conquer. So common factor there is 2x, x plus 5, and here it's going to be negative 1, x plus 5. So collect the terms inside and outside, 2x minus 1 and x plus 5 equals 0. See why your algebra is so important. So I'm going to set both of these equal to 0. So 2x minus 1 equals 0. So add 1 to both sides. So x must be half. And x plus 5 equals 0. X would have to be negative 5. So we have 2 turning points. So what we're going to do is we have to work out which does, so it's a trinomial, so does it look like that or does it look like that? So what we're going to do is we're going to take some point between negative 5 and half, and I'm going to say 0. Reason I'm going to do that is because it's just easy to work out. So I'm going to put 0 in here for x. So 2 times 0 squared is 0, plus 0, 9 times 0 is 0, is negative 5. So it's decreasing at x equals 0. So therefore it must be increasing between negative infinity to negative 5. Yeah. And then increasing again from half to positive infinity. So therefore it's increasing when x is greater than negative infinity, but that doesn't really help us, and x is less than negative 5. So x is, oh god, greater than negative infinity, equal to, and less than or equal to negative 5. Actually, it wouldn't be equal to, it would just be straight out greater than, wouldn't it? And when x is greater than half. So really we don't really need that at all, really, do we? So when x is less than -5 and when x is greater than half. And that would be our final answer for that. All right, we're back again. There was a particularly nasty gust of wind that came in and it blew something over outside. I think a flower pot. So a rectangle ABCD is 10 centimeters by 8 centimeters. A parallelogram, this thing in the middle here, EFGH, this thing, can be drawn on the side. Suppose the distance from each corner of the rectangle to the next vertex of the parallelogram on a clockwise, man, who writes these things, is x, as shown. Use calculus to find the smallest possible area that the parallelogram can have. Okay, so we need to turn this into some sort of function. So this whole rectangle is 8 centimeters by 10 centimeters, so it's 80 centimeters squared. Then I guess we can work out these areas here. That must be the same as this is the same as this. Just shouldn't really use an x if there's already an x there. So those are the same and these are the same. So this and this is going to be x, and this side here is going to be 10 minus x, isn't it? Yes. And that's going to be 10 minus x. And this from here to here is going to be 8 minus x. So, therefore, the size of the parallelogram is going to be the big rectangle minus x times 10 minus x Wow, listen to that wind, man. That is crazy. That's no way that's 130. Wellington, man. If it's not the wind, it's the earthquakes. And this side here is going to be x times 8 minus x. That's going to be the area of that parallelogram. So 80 is the big parallelogram. This one here is this plus this. See its side x times 10 minus x times 2. And this bit here is this triangle and this triangle. See it? So that's going to work, and we need an extra parentheses there. So let's expand this out. 80 minus 10x minus x squared minus 8x minus x squared. So that's going to be 80 minus 10x plus x squared minus 8x plus x squared. So we've done with that diagram, thank goodness. So let's collect up the terms here. 80 minus 18x plus 2x squared. So that's going to be the area. All right, so we want to maximize that. So if that is a as a function of x, if we differentiate that, we're going to get minus 18 plus 4x. Yes. And to find the turning point, the maxima or minima, we're going to set that equal to 0 and solve. So 4x is going to be equal to 18. Divide both sides by 4. So x is going to be 9 over 2. Okay, is that a maxima or a minima? A dash dash is just going to be 4, which is greater than 0, so that's a minima. So it's minimized when x equals 9 over 2. So calculate the smallest possible area that the parallelogram can have. Okay, so we're going to go into this one here, and we're going to put in 9 over 2. So 80 minus 18 times 9 over 2 plus 2 9 over 2 squared. And I'm going to just go to my calculator and solve that. So 80 minus 18 times 9 over 2. Okay. Plus 2 9 over 2 square equals 79 over 2, 39.5. So 39.5, and the units is centimeters, and its area, so it's going to be centimeters squared. So that would be our final answer, 39.5 centimeters squared when x is that. Oh. Okay, so for this one, I just want to show you a nifty trick. So we've got the function f of x here, and we're told to graph the function that's the derivative of that. Okay, how would we do that? Well, we could do it sort of bluntly. So when we derive it, it's going to have a positive slope from there, from negative infinity to that point there, and it's going to be negatively sloped there, negative meaning below the x-axis, and it's going to be positively sloped there. So it's going to be a straight line, and it's going to cross the x-axis directly below. So it's going to sort of go like that when we differentiate it. Okay, but I just want to show you a little trick. How could we find the actual equation of this parabola? So grab your calculator, go to menu. I'm going to go to stat mode, and I'm going to do a quadratic regression. So I need 3 points. So we've got 3 points. We've got negative 1, 2, 3, 0. So negative 3, and then negative 1, and then positive 1. We're going to go across. So negative 3, 0. See how these match up? Negative 3, 0 is a point. And this is up 1, 2, 3, 5, 6, 7, 8. So negative 1, 8 is a point. And positive 1, 0 is also a point. So enter those 3 points into the calculator in statistics mode. So then I'm going to graph 1, and you'll see that the 3 points are there. And then I'm going to calculate it, and I'm going to find a quadratic, so F4, and it's going to give me that equation in that form, ax squared plus bx plus c. So it's going to be, this is going to have the equation y equals negative 2x squared minus 4x plus 6. See there, negative 2, a is negative 2, b is negative 4, C is 6. The R squared is 1, which means it's a perfect regression. There's no error terms, and we can even draw that parabola. So these are the same parabola there. It's sort of a slightly different scale, but these are equivalent parabola. So we know that this equation is there. So then when we differentiate that, it's going to be minus 4x minus 4. So I've got this the wrong way around. So it pays to do it, doesn't it? That would make sense. Yeah, that would make sense, because from here it's positive. It's sloping upwards from negative infinity to this point here, and then it's sloping downwards. So it's going to sort of cross it there, and it's going to go down, kind of like that. Again, this is a maths class, not an art class. Thank goodness. Okay, a skyrocket is projected into the air. Do you project a skyrocket or do you launch it? Okay, that's strange. So that t seconds after it is launched, its height in h meters above the ground is given by this. What is the maximum height that the skyrocket will reach? Well, if the height at some time t is 39.2 t minus 4.9 t squared, when we differentiate that, we're going to get 39.2 minus 9.8 t. And if you recognize that 9.8, gravity is 9.8 meters per second squared. That's probably where that comes from. We're going to set that equal to 0 and solve for t. So equals 0. So I'm going to take, so negative 9.8 t equals negative 39.2. So t is going to be negative 39.2 divided by negative 9.8. The negative's going to cancel, and the end answer we get out of that screen. So 39.2 divided by 9.8 is 4. So 4 seconds after it leaves, gravity starts winning, and that's going to be at the maximum height. So the maximum height, we're going to put this 4 into this original equation. So 39.2 times 4 minus 4.94 squared. And I'm going to grab the calculator and do that. 39.2 times 4 is that. So that's how high it would be if there was no gravity. Minus 4.9 times, and 4 squared is 16. 78.4 meters. And it's in meters, so our unit is correct. Here's our final answer, 78.4 meters. All right, Adam is operating his drone, not in this windy snot. It is moving in a straight line, okay? T seconds after passing a tree, its acceleration in meters per second is given by this. Okay, so it's a kinematic equation. 2 seconds. So when t equals 2, after the drone passed a tree, its velocity was 20 meters per second. So in other words, v2 is 20. How far was the drone from the tree when its velocity was 20 meters per second? In other words, when t equals 2. All right, they give us a lot of information there. So they give us the acceleration, and we don't know what the initial velocity was, but we can probably work it out. Okay, so if they give us the acceleration, so the velocity the velocity at time t is this integrated with respect to time. So when we integrate 6 minus 12t with respect to t, we get 6t minus 12t squared over 2 plus c. We don't know what the c is, but we know one of the points, so we can find c. So when t equals 2, velocity equals 20. So 6 times 2, and this is going to cancel as -6. -6, 2 squared plus c equals 20. So 12 minus 2 squared is 4. 6 times 4 is 24. Plus c equals 20. So c is going to be 20 plus 24 minus 12. So 44, 30, 32. So c is going to be 32. So it's going 32 meters per second when it passed the tree. So in other words, velocity is going to be 6t minus 6t squared plus 32. And we want to know how far the drone has gone when its velocity is 20 meters per second. Now, what was the initial distance? Well, the distance from the tree to the tree is 0. So the c in this case, the sort of second c, is going to be equal to 0. So I'm going to say like c2 is 0, and I'm going to call this c1. Call it c1 there. So then we've got velocity. To find the distance covered, the displacement, we need to integrate this again. So we're going to integrate this. Let's move it up a bit. We're going to integrate 6t minus 6t squared plus 32 with respect to t. And we're going to get 6t stays there. Now it gets a 2. We have to divide by 2. Minus 6t, the 2 becomes a 3, and we have to divide by 3. Plus 32t plus 0, because the distance from the drone to the tree is 0 at time 0. That makes any sense. So here's the tree. It's a terrible tree, and the drone is kind of there. At time equals 0, this distance is nothing, and then 2 seconds later we want to know this distance 2 seconds later. Okay, we know that this is going to be calculated where t equals 2, but let's simplify things a bit more. So that's going to be 3, and it's going to be -2. So 3t squared minus 2t cubed plus 32t is going to be the distance. And then we're going to put in 2. So 3 times 2 squared minus 2 times 2 cubed plus 32 times 2. So 2 squared is 4. 4 times 3 is 12. 2 cubed is 8. 2 times 2 times 2 is 8. Times -2 is -16. And 32 times 2 is 64. So if we add those together, 12 minus 16, well, it's going to be -4, plus 64 is going to be 60. So after 2 seconds, it's gone 60 what? Units is 60 meters. And there's our answer. So a lot of information is in there. So extracting the information and sort of pre-working it before you start integrating differentiation really helps a lot in this question. Not too hard a question, but a lot of work there. There's a lot of hickory jiggery pokery going on here. Right, back at it. The gradient function is this, and the original function, so y goes through this 0.17, find the equation for y. So we want to integrate that. When we integrate something which has already been differentiated, with respect to that, we get y back. So we need to integrate that. So if dy dx is negative 5x to the power of 4 plus 6, then y must be equal to negative 5x, and the 4 becomes a 5. We have to divide by 5 plus 6x. And don't forget the c, and this is where the 17 bit comes in. It tells us that when x equals 1, y equals 7. And they're going to cancel. They're going to just go to 1. So negative x to the power of 5 plus 6x plus c. So negative 1 to the power of 5 plus 6 times 1 plus c equals 7. So 1 to the power of 5 is 1. So negative 1 plus 6 plus c equals 7. So c is going to be 7 plus 1 minus 6 is 2. So that means the original function, when we get it back, the c is 2. So it's going to be negative x to the power of 5 plus 6x, and we know what c is. That's our original function there. Suppose that at the start of a particular day, 1,000 people are trading in a market, and that t days after the start of the day, the number of traders n can be modeled by this. How many days will it take for the rate of change to be 1440? So in other words, differentiated when it's changing by that rate. All right, so if n of t is 1,000 plus 400t plus 100t square, then t prime of t, n prime of t is going to be 400 plus 200t, and we want to set that equal to 14,400 and solve for t. So I'm going to take 400 away from both sides, which is going to be pretty trivial. So 200t equals 14,000. So t is going to be 14,000 over 200. So that first 0 goes, the second 0 goes. So 140 over 2. So t is 70. So 70, and what's the unit? 70 days. Yeah, okay. That's our answer. It should be harder, but that's the answer. Okay. Back again with these great things here, how I love them. So diagram below shows f dash of x, so this is f prime of x, of a function y equals f of x, and I kind of cut off the end there. So this is after we've derived it, and essentially they want us to draw the other diagram. They want us to draw what that would be if we integrated that. So let's kind of do our trick with the calculator. So let's go to stat mode again, bring it over a bit, go to stat mode again. So this is the parabola that we did last time. So we need three places, three obvious places. One there. So negative 2, 0. And this is, yeah, it crosses it there, -1, -1, 2, 4, -1, and it crosses there at 1, 2, 3, 4. And then we go across. So this is 2, 0, the same, but, and then this is -1, -4, and this is 4, 0. There's a 0 already in there, but I'm going to put it in. Okay, graph 1, calculate the graph, and we want to graph a parabola. Okay. Ooh. So we've got some really, really close. So this is essentially 0.8. Okay. So it's 0.8x squared minus 1.6x minus 6.4. I'm going to ignore these 999 bits. Okay. So we know that's the derivative, that's the equation of this line here, which is a derivative itself. So we need to integrate that. I'm just sort of thinking loud. So when we integrate that, the 0.8 stays there. The x becomes a 3, and we have to divide by 3, minus 1.6 x squared over 2 minus 6.4 x plus c. But we don't necessarily know what the c is, but they do give us 0, 3. So we know that the c must be 3. So this function that we're going to draw here is going to be 0.8 over 3 x cubed minus 1.6 over 2 x squared minus 6.4 x plus 3. Okay. And then we would put that into our calculator and graph it. Right, back again. So let's go to menu and let's graph it. So I'm going to put 0.8 over 3 x to the power of 3 minus brackets 1.6 over 2 x squared minus 6.4 x plus 3 is that. And when we come to draw it and we zoom and auto, it's gonna, wow, it's gonna look really funky. So we're going to zoom out a little bit. Here we go. So when we come to draw it, so it goes through the point 0, 3, 1, 2, 3 there. So it's going to kind of look, and then it's going to have a turning point here. So it's going to sort of go like that. Going to sort of look like that, rough shape. Again, this is a maths class, not an art class. So the graph of the function y equals x cubed minus 6x squared plus kx, that's going to cause us some problems, minus 5 has a turning point when x equals 3. Use calculus methods to find the coordinates of both turning points. All right. Determine the nature of each turning point. So in other words, they want you to differentiate twice. justifying your answer. Okay, so we know that when we differentiate this, we and put in x equals 3, we're going to get 0. So if y is x cubed minus 6x squared plus k of x, we need to find what this k is. Then when we differentiate that, we're going to get 3x squared minus 12x plus k. That looks like a times, but it's plus k. And we know that equals 0 when x equals 3. So now we can solve for k. So 3 times 3 squared minus 12 times 3 plus k equals 0. So 3 squared is 9. 3 times 9 is 27. 12 times 3 is 36. Plus k equals 0. So k is going to be equal to 36 minus 27. So what's that? 9. So our original equation, therefore, is x cubed minus 6x squared plus 9x minus 5. That's our original equation. So we don't need to worry about this one at all now. And then find the turning points. So it's already differentiated for us, but now we know that k is 9. So 3x squared minus 12x plus 9 equals 0 at the turning points. So straight away I'm going to divide both sides by 3. So we've got x squared minus 4x plus 3 equals 0. We can do it when we're trying to solve for x, but when we come to differentiate, we can't do that nifty trick. So now I'm going to factorize that. So 3 is going to be, so x minus 3, x minus 1 equals 0. So x minus 3 equals 0 and x minus 1 equals 0. So x equals 3 and 1. Positive 3 and positive 1. Then we want to find which one is maxima or minima. So we're going to go to the differential equation. And we're going to differentiate it again. So it's going to be 6x minus 12. And we're going to put in 3 and put in 1. When we put in the 3, 6 times 3 is 18 minus 12 is greater than 0. So therefore that's a minima. And 6 times 1 is 6 minus 12 is a number which is less than 0. So that's going to be a maxima. Okay, what does the question ask? Find the coordinates of both turning points. Okay, so then we have to go into the original equation and find the turning points, and I'm too lazy to do that, so I'm going to do it on the calculator just to show you how it's done. So let's go up there, let's get rid of the last function that we did. So our original function now is going to be that. So it's going to be x cubed minus 6x squared plus 9x minus 5. We're going to draw it. So it's this funky thing here. We see the maxima there and a minima there. So let's go to GSolve. Let's find the maxima. 1, negative 1. So 1, negative 1. There's a maxima there, and a minima is at 3, So G-solve, we want to find the minima. 3 comma minus 5. Here we go. There is our answer there. And there's our proof. Good question. Really good question. Right. School is selling tickets for its drama production. Fantastic. Good for us. The revenue are dollars, is P dollars each. Can be all right, fair enough. Can be modeled by this function. Use calculus to find the maximum possible revenue using this model. I don't like that brackets there, so I'm going to expand out that bracket. So 40 times 29. Don't know my 40 times tables. $1,160. Wow. And it's going to be P minus 80 P squared. That's going to be your revenue. Who worked? Okay. Who would work that out? I mean, what crazy messed up world does the drama department do econometric modeling to get that answer? What world does this exam live in, where people are flying drones, they're projecting rockets into the air, they're having drama where they want to maximize the revenue? Okay, fair enough. Let's just go with it. So we've got that. So that's our revenue function, and we want to maximize it. So we're going to need to find the derivative. So when we do that, it's going to be 1160 minus 160p, and we're going to set that equal to 0 and solve p. So minus 160p equals minus 1160. So p must be equal to 1160, and the negatives are going to cancel. And I don't know what that is. 60. $7.25. Do they want us to prove that it's a maxima? No, we're just going to say that it is. So they want the maximum possible revenue. Okay, well, it's going to be 1160 times 7.25 minus 80 times 7.25 squared. Cool story, bro. So 1160 times 7.25 is that, minus 80 times 7.25 squared is that. So 4205. And that's our final answer for that. All right. I'm looking at this one, and I don't think you even need calculus to solve this one. Okay. So tangent to the graph. So tangent is always a straight line of the function that has a gradient of minus 7 and it intercepts it there. Find the coordinates of point P. So okay, so we can find the equation of the tangent because we've got the gradient and we've got one of the points. So y minus 64 equals minus 7, x minus minus is plus 6. So y equals minus 7x minus 42 plus 64. Oh. Minus 42 plus 64. Sorry if this is 22. So y equals minus 7x plus 22. Okay. So we need to find out what this k is, don't we? But we've got one of the points. So why do we need calculus? Okay. So let's take this one up here, and we know that it goes through the point negative 6, 64. So y equals negative 1 over 3 x cubed plus kx plus 4. And we don't need calculus. Okay. So 64 equals negative 1 over 3 minus 6 cubed plus, just going minus 6k plus 4. We've got one equation and one unknown. Strange. So let's cheat. Go to the solver so you can see how it works. Equals negative 1 over 3 negative 6 cubed negative 6x plus 4. K equals 2. Okay. So k equals 2. So now it's really just a simultaneous equation. Okay, but let's use calculus. Just go out of our way to use calculus. So we know that k is 2. So if y is now going to be negative 1/3 x cubed plus 2x plus 4, so therefore dy dx equals 3 times a third is negative 1x squared plus 2, and we're going to set that equal to 7, negative 7, and solve. So negative x squared equals negative 9. So x squared equals 9. So x equals plus 3 and minus 3. And we know, so it's got to be one of those two. Okay. So let's test one of them out. Let's test them both out. So negative 7, positive 3, plus 22. Does that equal negative 1 over 3, 3 cubed plus 2 times 3 plus 4? So I'll show you another. Let's do a logic sequence using the calculator. So negative 7 times 3 plus 22 equals negative 1 over 3. 3 cubed is 27. Plus 2 times 3 is 6. Plus 4. Yes, it's true. So at 3. So 3, and does negative 3 work as well? Ugh. Oh well, let's just totally cheat. Get out of there. And let's just graph them both together. That's the last graph. So our graph, one of the graphs was negative 7x plus 22. And the other one was negative 1 over 3 x to the power of 3. Listen to that wind. Plus 2 x plus 4. And let's draw them. So there we go. Sure enough, there's 1 point. So that's the tangent at point P. And my bet is if we zoom out, it's going to give us the other point here. So we can G-solve where do they intercept? Negative 6 and 64, which is that one. And the other one is at 3, 1. So it's at 3, 1 is the tangent point. So we want the other one though. So that's the tangent point is there. And the other one was at negative 3, 64. So P is at negative 3, 64. I guess we'd need to use calculus, but you don't really need to use calculus for that. Oh, okay. All right, well, that's the end of that test.